9-7 tessellations. Tessellations is a design or pattern in which a shape is used repeatedly to cover a plane with no gaps, overlaps, or empty spaces. Regular tessellations. A pattern made with only one type of regular polygon. So regular polygon has same size, and congruent angles. Semi-regular tessellation. The same combination of regular polygons meet at each vertex. Irregular tessellation. Formed by irregular polygons of either the same or varying types. So semi-regular is combination of regular polygons, the same combination of regular meet at each vertex. Irregular is formed by irregular polygons, just like normal polygons, and of either same or varying types. So let's look at some example here. This is an example of tessellation. This is a regular polygon, and these are all regular polygon, and this is a regular tessellation. Tessellation is a pattern made with only one type of regular polygon. So you have here hexagon. So this is a regular tessellation, is a pattern. This one is semi-regular because you have a hexagon here. And then 1, 2, 3, 4, 5, 6, 7, 8. So you have octagon here, and then you're going to you have also a square here, right? So it's a semi-regular, the same combination of regular polygons meet at each vertex. So if you look at this vertex, they meet at each vertex. That's why I circled here and here. Those are vertex. So this is a square, which is a regular polygon, octagon, regular polygon. They meet each other like this at their vertex. This is semi-regular tessellation. And then this one is irregular because some of them are just, they're not regular polygons. They're different lengths. So this is an irregular pattern. So this is a regular polygon pattern, tessellation, semi, because you have two regular polygons making patterns, and this one just irregular pattern, so irregular tessellation. This one, you look at circle here where they meet. This is semi-regular because you have a equilateral triangle and a square, and they meet at the vertex. This one is irregular because you have a different shapes here, concave, convex, different shapes. So that's irregular tessellation pattern. Key information about tessellation. Sum of the measures surrounding a point or vertex always equals 360. Only regular polygons that have an interior angle, which is a factor of 360, would tessellate. No regular polygon with more than 6 sides can be used in a regular tessellation. Can be used equilateral triangle, square, but pentagon you cannot use them, and hexagon you can use. So the word tessellate means cover the surface using single shape without gaps or overlapping. It's like those mosaic tiles on the floor or some on the wall, like mosaic tiles. Those are tessellation. So these looks like tiles here, right? And then there are no gaps between them, and they're single shape, and you have different types of tessellation. This is like pattern, you know. Think of mosaic tiles. Alright, so next thing we're going to do is areas of triangles and quadrilaterals. Area postulate. Area postulate there's an area congruence postulate. If two polygons are congruent, then they have the same area. Area addition postulate. The area of region is the sum of the areas of its non-overlapping parts. So let's take a look at the area formula. Rectangle is area is length times width. Parallelogram area is base times height. So base and the height. The height is always perpendicular to the base and makes 90-degree angle. So the base is the side that is being hit by the perpendicular, right? Something like that. Triangle area is half times base times height. Trapezoid is half times height, parentheses base 1 plus base 2. So these are all the area formulas for quadrilaterals. Kite, the formula is area is half D1 and D2. D1 stands for diagonal 1. Please write this. D2 stands for diagonal 2. So can you guys write this on your notes? Rhombus area is half times D1 and D2 also. So they have the same formula. Put a star on these two because those are new formulas, okay? So find the area of a figure. So let's say, pretend I want you to write inches for this. So this is a square because you have 90, 90, 90 and 4 congruent sides. So 4 by 4 is 16 square inches. That is the area of this square. This rectangle is 5 by 2. Let's say it's centimeter. Then you're going to write 10 square centimeters. So because you're multiplying length times width, you need to put square inches and square centimeters when you write the area. The area of a triangle is half a parallelogram. That's why you do, if I put another triangle, it's half a parallelogram. So you do half times base times height. So half times 12 times 8. You can multiply these two and divide it by 2. 48 square yards. For this problem, do not worry about all this work. You need to find the height, which is 4. And then the area of ABC is you can do 5 times 4, which is 20, divided by 2, which is half. So half of 20 is 10. So area is 10. You don't have to worry about all of this work. You don't need to copy these. Just write half times 4 times 5, which is 10. So area of ABC right here is 10. Okay, so find the area of a trapezoid with vertices A, 0, 0, 2, 4, 6, 4, and 9, 0. So what you need to do is draw. So I'm just going to ask you to make a X and Y axis here. And do 1, 2, 3, 4. Do 1, 2, 3, 4, 5, 6, 7, 8, 9. I want you to draw this and label it A, B, C, D. So A is 0, 0. B is 2 and 4. So put the B. C is 6 and 4. D is 9, 0. So I want you to draw this. Pause the video and draw this. And then once you draw that, we're going to use the area of trapezoid, half times height times base 1 plus base 2, using the units. So on the bottom, you have 9. So, and then on the top, you got 4. And then the height is from here to here is 4. So what we're going to do is half times 4 times 4 plus 9. 4 plus 9 is 13. Half times 4 times 13, you can do that on the calculator, that's 26. Find the area of parallelogram ABCD. So right here, we're going to look at this as a height. It's 90. So what we're going to do is the base is always perpendicular to the height. So 16 times 9, which is base times height, 144. You don't need 12, okay? That's not the height or the base. So remember, the base and the height makes perpendicular. Find the area of a trapezoid with 8, 1, 1, 1, 2, 5, and 5, 5. So let's do another one. I want you don't have to draw this. You can just look at this picture for this one. You don't need to draw this picture. You can just look. 1, 1, 2, 5, 5, 5, and 8, 1. So from the height from here to here, what will be the height? will be 4, right? 1, 2, 3, 4. And then from here to here, there's 1, 2, 3 units. And that's base 1. Base 2 is 1, 2, 3, 4, 5, 6, 7. So you're going to write this down. Area is half times height, parentheses, base 1 and base 2. Half times 4 times 3 plus 7, 20. Find the area of the rhombus ABCD. So please write this. This is a new area formula that we haven't seen before. So area of a rhombus is half times diagonal 1, diagonal 2. So D1 means diagonal 1, D2 means diagonal 2. So what we're going to do is to half diagonal 1 is 20, and 20 from here to here is 40. So write 40. That is your diagonal 1, this red line. And then diagonal 2 is from B to D, which is this blue line, 15 plus 15, 30. So you do half times 40 times 30, which is 600. Because 40 times 30 is 1200 divided by 2 is 600. Let's look at the kite. Kite has the same formula as this, half times D1 and D2. So what we're going to do is the area of the kite is 160. So write 160. They're giving you the area. Find the length. So we're going to do half times D1 and D2. So D1 is right here. D2 is right here. That's what the height of this kite is. If I put the string here, that is the height of the kite. And then right here is the D1, which is 20. 10 plus 10, 20. And then this is D2, which is what we're looking for. Half times 20 is 10. 6 divide each side by 10, 16. So x equals 16.